So which one of the following crystal does not belong to the ditetragonal pyramidal class? So the data type question. So ditetragonal pyramidal class does not include the tetragonal dipyramid. You have to remember all the form. So a ditetragonal prism of first order, they all belongs to prismatic class, and this pedian also, C pedian, it will, does not belong to pyramidal class. So tetragonal dipyramid will belong to ditetragonal pyramidal class. Sorry. So which one of the following crystal form does not belongs to ditetragonal pyramidal class? You can say this prism of first order ditetragonal prism, that doesn't belongs to the ditetragonal pyramidal class. Pyramidal class are tetragonal dipyramid and pedian. You'll find it in textbook of GBM or textbook of GB Mahapatra book. You'll find this. So group 1, you have to match for the composition. The leucite has composition KAlSi2O6. Then andradite, it is a garnet. So it will have a silicon oxidation 1:4. So it will be Ca3Fe2Si3O12 garnet. Cyanidine, it is orthoclase. Then it is KAlSi3O8. Then jadite, it is alkali pyroxene. So NaLSi2O6. So leucite, your KAlSi2O6. So this P is 3. Then Q, it is 4. Then R, it is 1. S, it is 2. The last one is the answer. And choose the correct pair of crystal system that represents the optic orientation shown in figure. X, Y, Z are principal optic vibration direction and A, B, C are crystallography axis direction. So in biaxial mineral, we will get 3 indicatrix axis, that is X, Y, Z, you can say vibration direction. Only in case of orthorhombic system, all the indicatrix axis will coincide with the crystallography axis, which you can see here in this diagram. All the axes X, Y, Z, they are coinciding with the crystallography axis. Here Y is coinciding with B axis, Z is coinciding with A axis, and X is coinciding with C axis. So this figure, it belongs to orthorhombic system. Then the next one, that is, you're in monoclinic system, only one crystallography axis will coincide with any of the indicatrix axis. Here B crystallography axis, it is coinciding with Y, and all other are not coinciding here. You can see this is the orientation of X, this is the orientation of Z, so they are not coinciding with A or C. So it will belongs to monoclinic system. So it will be orthorhombic and monoclinic system. So first one is orthorhombic, second one is monoclinic. And in triclinic system, none of the indicatrix axis will coincide with any of the crystallography axis. The answer will be orthorhombic and monoclinic. Then which of the mineral among the following represents Ab2O4? Ab2O4, remember, this is the general formula of spinel group. This is the general formula of spinel group. The spinel group, it includes spinel, magnetite, chromite. These three, they are included within the spinel group. Let's also try 22%. In the hollow symmetrical classes of cubic system, how many more faces does the 1-1 knot form have compared to 1-1-1 form? So 1-1 knot form, it is your dodecahedron, hadron. So it has 12 number of faces, and 111 is your octahedron. So octahedron has 8 number of faces. So dodecahedron has 4 more number of faces than octahedron. So answer will be 4. Then realgar and orpiment are both mineral of arsenic and have the same chemical composition. Both have same chemical composition. Which one of the following properties can be used to distinguish between the two minerals? So realgar and orpiment, they are distinguished on the basis of their color. So realgar will find reddish or orangish color, and orpiment it is yellowish color. So color is the distinguishing property between realgar and orpiment. Then what is the minimum number of forms that an actual crystal must contain in class 1 pedal of the triclinic system? So minimum number of forms in class 1 or pedal class, remember it is 4. There are 4 number of form under pedal class. Which one of the given statement is correct? Van der Waals bonding is absent in silicate minerals. So van der Waals bonding, it is your very weak bond. The silicate, we have bond between Si and O. So those the bond between Si and O, that is your, you can say partially or partly covalent. Partly covalent. Remember this is very important. Partly covalent, partly ionic. So the bond of silicate structure is partly covalent, partly ionic. So van der Waals bonding, that is also present in silicate structure. Sorry, absent in silicate structure. So van der Waals bonding, it is absent in silicate structure. You will only find covalent and ionic bond. So silicate bonds are partly covalent, partly ionic. Then sulfide minerals formed by covalent bonding between metals and sulfides. So it is a characteristic of sulfide minerals. It produces by covalent bonding and it produces between metal and sulfur. So most of the metallic things are sulfides. So this should be correct. Then silicate minerals have a significant component of metallic bonding. Silicate mineral doesn't have metallic bonding. Then metal sulfide formation does not involve splitting of d orbitals. So metal sulfide will forms because there will be covalent bond and there will be splitting of d orbitals. So this one will correct and all other three are incorrect. Then as the minerals group 1 with their optical properties, this is sodalite. Sodalite is a mineral that belongs to isometric system. So it will be isotropic. So it will be 2. Tourmaline, it very important, it shows pleochroism. So pleochroic is tourmaline, which show pleochroic from blue to brown. Then calcite, it is main characteristic is a twinkling effect, like all other clay minerals, they also show twinkling effect. So R will be 4. Then muscovite, it shows motile extension or bird's eye extension. So this will be, so this is the characteristic. So P2, Q3, R4, H1. This one the answer. So which one of the following symmetry element is an incorrect represents of roto inversion operation? So we know 3 bar operation, it is threefold symmetry plus inversion. So it is correct because one A3 represents threefold symmetry and inversion, that will be produce 3 bar symmetry. Then 1 A2 equal to 4 bar. So this is incorrect because 4 bar operation it is does not equal to any operation. So this will be your incorrect and this will be the answer. Then mirror plane, we know 2 bar it is equivalent to a mirror plane. Then 6 bar it is equivalent to threefold axis by mirror plane. So A, C, D are correct, only B is incorrect. So answer will be B. So which of the following optical properties correctly identifies the apatite? Not one section. So apatite, it belongs to hexagonal system. Hexagonal system, and this not one section, it is basal section. So the basal section of a hexagonal mineral or tetragonal mineral is isotropic. So that's why the section will be isotropic under cross-nickel. Then it can show centered uniaxial interference figure. It can show centered uniaxial interference figure because of in basal section the optic axis is perpendicular to the microscope space and doesn't show secondary order interference color or doesn't have any high pi refulgence. So it will be A and C. The answer will be A and C. So basal section of any hexagonal or tetragonal mineral is, you can say, this is isotropic. So this is the previous year question, 2024. Which of the following is an amorphous variety of SiO2? Here is opal, it is amorphous variety. Agate, it is a concentric variety. Citron, it is yellow quartz, the crystalline variety. Okay, quartz is also a crystalline variety. So opal, it is your amorphous variety. Amorphous variety will not find any grain. So or crystal, you can say amorphous variety of silica is opal. So match the following mineral group with highest order interference color for 0.03 mm mineral thickness. Here you remember always quartz show fast order. Okay, quartz show fast order. Then sillimanite it show second order. Sillimanite show second order. Okay. Then moscovite it show third order, and calcite it will show greater than third order. So this thing will be known from the birefringence. Calcite has higher birefringence 0.142, and all of other likely the quartz has very less birefringence 0.009. So from that you have to remember. Otherwise you have to remember the simple order of interference color of individual minerals. So answer will be P2, Q1, R4, S3. So crystal form dome contains. So dome is a form which has two non-parallel faces and they are characterized by a mirror plane. So two non-parallel faces related by a mirror plane. If they have two non-parallel faces related by a two-fold axis, then it will be sphenoid. So answer will be D, and this thing will be sphenoid. And only you have two parallel faces, they are called as pinacoid. Pinacoid, only two non-parallel faces. If you have two parallel faces, this is pinacoid. If you have two non-parallel faces, it is dome or sphenoid. Dome is characterized by a mirror plane, sphenoid is characterized by a two-fold axis. Then the symbol, you have to remember this. A square bracket, it always indicate an axis. So it will be line. Then this curly bracket is represent form, and this simple bracket it represent face. So square bracket, line, curly bracket, form, simple bracket, face. The answer will be D. Which of the following corresponds to a pyrogen group? Here CaMg Si2O6 diopside, it is belongs to pyroxene. Then NaFe Si2O6 ethylene, it belongs to pyroxene. Then this Ca2Si2O6, it is your CaSiO3. It is elastonite, doesn't belongs to pyroxene, it is belongs to pyroxenate group. And this thing, it belongs to pyroxene group. So these three A, B and D, they belongs to pyroxene group. So this is all about your MCQ and MSQ question starting from 2015 to 2024. When the birefringence of a uniaxial mineral having refractory indices of 1.658 and 1.468. Do you know birefringence? It is high Ri minus low Ri. High refractory index minus low refractory index. So your high refractory index is 658 minus 1.486. So if you subtract it, it will be 0.172. 0.172. So this will be the answer, 0.172. Then crystal phase of the following intercept to the crystallography axis: 1A, 1A, half A3, infinite C. Write down again here: 1A1, 1A2, half A3, infinite C. So you have to calculate the Miller-Brabus indices for this phase. Just take the reciprocal one by one, then we'll take the reciprocal one by 2, 1 by infinity. Will be 1, 1, 2, will be 0. 1, 1, 2, 0. So just take the reciprocal. The total number of mirror planes in the point group is given 4 by n, 3 by 2 by n. So I have to find out what is the total number of mirror plane present here. So this is the hexaoctahedral class, belongs to isometric system. You just write down 3, 4, 6 above it. So here we have 3 axial mirror plane and 6 diagonal mirror plane. Total we will find 9 mirror plane. So answer will be 9. So the calculate the average atomic weight. So first the isotope rubidium 85, rubidium 87, they have an atomic weight of 84.91 to 86.909 and they have abundance of 72.17%, 27.83%. So rubidium 85, when it is 100%, it weighs 84.992. Now it is, the abundance is 72.17%. So we have to calculate the atomic weight of the rubidium 85 when it has the abundance of 72.17. Then we have to calculate rubidium 87 weight when it has an abundance of 27.83%. So we'll say weight of rubidium here, it will be 84.912 into 72.17%. Then weight of rubidium 85, then weight of rubidium 87, it will be 86.909 into 27.83%. So isotope of rubidium, when it has abundance of 72.17, it has weight of 61.280. Then weight of rubidium 87, it has When abundance is 27.83%, it is 24.18077%. So now, what will be the average atomic weight of rubidium? So average atomic weight of the rubidium will be, it will be weight of rubidium 85 plus rubidium 87. It will be 61.280 plus 24.186. You can consider other decimal also. So you have to give answer up to 3 decimal. So only take 3 decimal, 85.467 approximately. This will be the average atomic weight of the rubidium. So average atomic weight, how we will calculate? See, you can write down this also. Average atomic weight. Isotopic abundance. Isotopic abundance into atomic weight. So the number of isotope you have to calculate these things, then add them. So isotopic abundance of rubidium 85 into its atomic weight, then isotope abundance of rubidium 87, then its atomic weight, then we'll add them to get the average atomic weight. So isotopic abundance into atomic weight, that will give the weight of the isotope. Then after getting that weight, we'll just add the weight of the isotope to get the average atomic weight of the element. Then a mineral has weight of 4.5 gram in air and 3.2 gram in water. Assuming the density water to be 1 gram per centimeter cube, the specific gravity up to 2 decimal. So write down the formula: specific gravity, weight of mineral in air by weight of mineral in air minus weight in mineral in water. So weight of mineral in air, it is given 4.5 gram divided by 4.5 minus 3.2 with 3.46. It will be 3.46. So from the given equation, calculate how many moles of magnetite will be produced by the reduction of 1 mole of hematite. So this type of question, when you see, first you have to see the equation and you have to identify which is your hematite, which is magnetite. This one is your magnetite, this was your hematite. So in this equation, it is written 6 Fe2O3, it is producing 4 Fe3O4 plus O2. That means 6 moles of magnetite, hematite produces 4 moles of magnetite. From this equation, you can see 6 moles of Fe2O3. When it will break, it will produce 4 moles of Fe3O4. So we have to calculate how many moles of magnetite will produce from 1 mole of hematite. So 6 mole will produce 4 mole. So 1 mole will produce 4 by 6 moles with 0.66. Up to 3 decimal, you can write down 0.666. based on the ideal end member formula of diopside. So what is the formula of diopside? CaMgSi2O6. So you have to calculate the mole proportion of Ca. So in this formula we have CaO, MgO and SiO2 oxides are present. So CO it is present 1 mole, MgO it is present 1 mole, SiO2 it is present 2 moles. So CO it is 1 mole, MgO it is 1 mole, SiO2 it is 2 moles. So we have to calculate the mole proportion of CO. So number of moles of CO, number of moles of CaO divided by total moles into 100. The number of mole of CO it is 1. Total mole we have 1 plus 1, 2, that is 4 into 100. It will be 25%. It will be 25%. Next comes to the following schematic diagram. The aluminum silicate, the triple point, it is at 4.50 kilowatt. Okay. And the temperature at this point is 823 kilowatt. Okay. So a reaction is proceeding here where andesites element they coexist with each other. So when the reaction is proceeding here, the temperature decreases from 823 Kelvin to 923 Kelvin. Okay. And the slope it has a negative value of minus 18.22 bar per Kelvin. So each change in pressure, each change in degree of Kelvin minus 18.22 bar pressure is decreasing. So it is showing that we have to calculate the pressure at 923 Kelvin. Okay. So this indicates that each 1 degree change in temperature or 1 degree change in 1 Kelvin change in temperature, the pressure is decreasing minus 18.22 bar. So here pressure is decreased 100 Kelvin. So it is from 1823 to 1923. So pressure decreases 100 Kelvin. So in 1 Kelvin, temperature decreases 18.22 bar. So in 100 Kelvin, it will decrease 18.22 into 100 bar. It will be 18.1822 bar. But if you convert it into kilobar, it will be 1.8 kilobar. It will be 1.8 kilobar. Then from this point to this point, the pressure decreases 1.8 kilobar. So initial point we have temperature 4.50. From this point it decreases 1.8 kilobar. So 4.5. So I have to just subtract 4.5 minus 4.5 minus 1.8. So it will be, this you have to write down 1.822 kilobar. Okay. So 1.822, it will be 2.678. Or you can write down 2.67. 2.67. Understood? So initially there are 4.50 kilobar pressure, then temperature decreases by 100 degree. So for 1 degree of temperature decrease, pressure decreases 18.22 bar. So in 100 it is decreases for 1822 bar or 1.822 kilobar. So after decreasing 1.822 kilobar, the pressure is now 2.67 kilobar and the temperature is 923 Kelvin. Then the mole percentage of phosphorite component in olivine with chemical formula Mg 1.8, Fe 0.2. So this place total it is 2. So Mg it is taken 1.8. So you have to calculate the mole percentage of phosphorite. So Mg is 1.8, 1.8 by 2 into 100 will be 90%. So the phosphorite composition here in olivine it is 90%. The weight symbol of crystal faces 4, 2 and C. 4A, 2B, C. The value of H in the corresponding Mill indices. So weight symbol is 4, 2, 1 means Mill indices will be 1 by 4, 1 by 2, 1 by 1. You can take the LCM. It will be 4, 2, 1. Sorry, 1, 2, 4. It will be 1, 2, 4. So the H place will be 1. H place will be 1. In the mineral chemical formula AT4O8, the ionic radius of A and O are given. So radius of A it is given 1.12. Radius of O it is given 1.40. So A is cation and O is anion. So we have to calculate the radius ratio here. Radius ratio it will be Ra by Ro. It will be 1.12 by 1.40. So from the radius ratio we can calculate the coordination number. So 1.12 divided by 1.40 it will be 0.8. So if the radius ratio fall between 0.732 to 1, then this is called as your 8-fold coordination number. That is 8-fold. So 0.8 it falls between 0.732 to 1. So the coordination number of cation A will be 8. Answer will be 8. Then aluminum occur in both tetrahedral and octahedral coordination in silicates. The amount of octahedral Al in pyroxene crystal of composition Mg 1.4, Fe 0.4, Al 0.4, Si 1.8, O6. So first we have to remember the general formula, that is Xy Z2O6. That means Z place, this tetrahedral place should be 2. So in this case Mg 1.4, Fe 0.4, aluminum it is 0.4, Si it is 1.8. So Si always takes the Z place. So Si it is now 1.8. So this place should be 2. Now it is 1.8 means we require 0.2. So that means aluminum is 0.2 in the tetrahedral and rest will be in the octahedral. So if you take 0.2, only 0.2 will be remain, that will be towards the octahedral side. So Mg 1.4, you can write down like this, Fe 0.4, aluminum 0.2. Okay, this will be 1.4 plus 0.4, 1.8, 0.2, 2, because xy they will be add up to 2. Then Si 0.2, sorry, Al 0.2, Si 1.806. So 6. So aluminum is also 0.2 towards the tetrahedral side and also 0.2 towards the octahedral side. So to complete the tetrahedral side, you require more 0.2, and also to complete the octahedral side, you require 0.2 alum. So the bireference of a mineral thickness is given 30 μm. So thickness it is given 30 μm. retardation it is given 0.27 mm. So you have to calculate the birefringence. So retardation equal to thickness into birefringence. So you have to calculate the birefringence. It will be 0.27 retardation divided by 30 μm, both is in μm. So 0.27 divided by 30 will be 0.009. So by reference will be 0.009. The core rim composition of a normally zoned plagioclase crystal are as follows. So this is core composition 0.6, NX, AL 1.6, SI 2.4, OA, core is here 0.4, NAY, AL 1.4, SI 2.6, OA. So amount of increase Na. So first I have to calculate what is the value of Na here. So the general formula of plagioclase or of feldspar WZ4O8. So Z place should be 4. So here you can see these two occupy the Z place. They are 4 here. Here is also 4. Here is also 4. These two occupy W place. But should be they should be add up to 1. So if 0.6 is calcium, then sodium here will be 0.4. And if calcium is 0.4 here, then sodium will be 0.6 because they should be add up to 1. So initially it was 0.4. Now it is increased to 0.6. So the amount that is increased is 0.2. The answer will be 0.2. Then considering the chemical formula in 12 oxygen bases, the number of Mg cations in garnet of chemical composition P. Chemical composition P here. So you can write down the formula here for composition P. Here pyrope, rosular and almandine are the 3 vortices. So pyrope here it is 25%. Pyrope is, from the diagram you can see pyrope is 25% because here pyrope is 100, on this line pyrope is 0. Then it is increasing towards pyrope. This is 0, 25%, then 50%, then 78%, then 100%. And it is similar for all other things. Almandine here 100%, on this line almandine is 0. Then on this line it is 25%, on this line 50%, on this line 75%, then 100%. So from that pyrope is 25%, then grossular is also it is 25%. Grossular it is 25%. Almandine it is 0, 25, 50%. Almandine is it is 50%. So if you write down a formula for this composition P, it will be pyrope Mg 25%, Fe is almandine at present 50%, and grossular that is Ca 25%. Then Al2, Si2, Si3O12. What is the general formula? X3, Y2, Z3O12. So this place is 3. So Mg is occupying 25%. Mg is occupying 25%. You have to calculate the 25% of 3. 3 into 0.25 will be 75. So 0.75. So Mg will be 0.75. So it is asked what is the composition of P. So you have to calculate the number of Mg cations in garnet chemical composition. The number of Mg cation is 0.75. Fe will be 1.5 and Ca will be 0.75. So number of cation will be in Mg will be 0.75. Similarly, you can calculate Fe, it is occupied 50%. So 50% of 3, it will be 1.5. So Mg will be 0.75. Fe will be 1.5. Ca will be 0.75. So it is asked the pyruv or Mg cation. So it will be 0.75. Diagram, it is a compositional diagram. Okay. So it is a compositional diagram where we can take different minerals at the vortices. So due to vortices, each vortices will indicate a mineral where that mineral is 100%. That indicate pyro is 100% here. Grossular is 100% here. Almandine is 100% here. Then the pyro value on a line parallel to pyro vortices is 0. If you say what is the value of pyro here, it is 0. Then gradually it is increased towards the pyro. So it depends upon how many divisions we are doing. So if we are doing 10 divisions, then each line will increase by 10. Here only 4 divisions are there. So that each line will increases by 25. This is 0. This line will indicate pyro value 25. This line will indicate pyro value 75. Sorry, 50. This will indicate 75. And this point will indicate 100%. And similarly, grossular value, it is 0 on this line and then increases towards the grossular 25, 50, then 75, 100. So this is called as a triangular composition diagram where we calculate the composition. And anything you will represent within the diagram, any point that will contain all the 3 components. All the 3 components are different composition or different proportion. So this thing will study elaborately in petrology part. Then the refractive indices of 4 minerals are given here. Okay, PQ, RS. So it is asked what is the maximum birefringence. Okay, so you just calculate all the birefringence. The maximum birefringence will be 0.172. So I have to subtract alpha from gamma from alpha. Sorry, alpha gamma minus alpha, then omega minus epsilon. So you just do the subtraction in each case. You will find the maximum birefringence in all. Highest will be 0.17. So this will be the answer.